All right, so we're going to do some acceleration practice problems. I'm going to do them up here on the Mimeo board. What I'll do is I'll write the problem, and then we will figure out together what we should use, make our charts, make our diagrams and things of that nature. The way that I am going to do this assignment or do these problems is the way I expect you to do these problems. So the first one, a car accelerates from rest to 20 meters per second in 5 seconds. What is the acceleration? What is the car's acceleration? Okay, so first things first, let's draw our scenario, what this is going to look like. So you have a car. This is where you all find out that I am not a Picasso. It starts from rest and is going to accelerate in the positive direction. So it's going 0.0 meters per second. And then when the car gets here, it's actually going 20 meters per second. Okay, and we know that this direction is the plus direction. This direction would be for acceleration would be negative. This way would be negative, obviously, for acceleration. And acceleration upwards, doesn't matter here, would be positive. Okay, all right, so that's your video, or your video. That's your diagram of what's happening here. Okay, now what you need to do is make your chart. Okay, so your chart will be your 5 variables: VI, VF, acceleration, time, and displacement. All right, so now let's go in and look at what we are given. Okay, so let's look at this. What's your initial velocity? From rest. Okay, so that means it's going to be 0.0 meters per second. That's what you're starting from. Okay, and what is your final velocity? Your final velocity is going to be 20 meters per second. Okay, acceleration is what you need to solve for. Okay, time, you have 5 seconds. Okay, and then you don't have distance. You're not given distance. But in the future, I'm going to tell you right now that you're probably going to have to fill out the entire chart that you have here. Okay, so you don't have distance and you're solving for acceleration, or displacement. So what you're going to do is you're looking at the kinematic equations, what the 5 kinematic equations are, and I have them on my handy dandy phone at the bottom, and it's at the bottom of the worksheet that these problems are coming from. It's going to be VF equals VI plus A times T. Okay, and that's when you don't have displacement. So you have final velocity, which is 20 meters per second. You have the initial velocity, which is 0, plus the acceleration times time, which is 5 seconds. Now you just solve. 20 meters per second equals 5A, which is actually in seconds. Remember that. How do you get acceleration? You divide by 5 seconds to get A by itself. And you're left with A equaling 20 divided by 4 is 4 meters per second, which is 4 meters per second squared. So your acceleration in this case is 4 meters per second squared. And that's this problem. It's the first problem on the acceleration practice problems that I posted in Google Classroom. All right, so that's this one. So a bus slows down from 30 meters per second to a stop in 10 seconds. What is the acceleration? All right. So again, let's draw our diagram. Okay. Now we're dealing with a bus, so this is going to be a little bit longer and a little bit more square. Yay! God, I am such a terrible artist. Okay, so this is moving at 30 meters per second. Okay, and it's still moving in a positive direction. Okay, the direction is positive. Okay, and the acceleration would be, that's an A. Acceleration would be positive going this way. Going this way, your displacement would be negative, and your acceleration would be negative. Okay, acceleration. What is going on? Would be negative. Accelerate if it's going up would be positive. Okay, so that being said, you have your bus that ultimately finally comes to a stop. Okay, so in 10 seconds. So now, next thing, what do? Draw your chart. Okay, and on any assessments, I will have the chart already drawn for you. So that way you don't have to worry about doing this part. So initial, final, acceleration, time, and distance. Distance you don't have in the problem. A bus slows down from 30 meters per second. Anytime you see from, that's going to be your initial velocity. So 30 meters per second is your initial velocity. What's its final velocity? What's it coming to? It's coming to a stop. Okay, so that's 0 meters per second. What are you solving for? Acceleration. And then your 10 seconds is your time. Okay, again, you don't have distance, so you're going to use the same equation that you used last time, which is VF equals VI plus AT. Okay, final velocity is 0. Your initial velocity is 30 meters per second plus A times 10 seconds. So when you write this all out, it's still going to be 30 meters per second plus 10 seconds A. Well, you got to get A by itself, so you have to subtract 30 from both sides. And you're left with 10 seconds A. To get A by itself, you divide by 10 seconds. This cancels, you're left with A and 10 seconds here. Okay, so you're looking at this and you're like, okay, I have a negative acceleration. Does that make sense? In the video yesterday, we talked about it. If the bus is moving in a positive direction, so the bus is moving this way, if it's slowing down, the acceleration has to be moving against it. Okay? It has to be moving against it. And if it's moving in a positive direction, the acceleration has to be negative. Okay? So this answer makes sense, and it's negative 3 meters per second squared. Okay? Anytime you have an object that's slowing down, it's got to be a negative acceleration. Right? That's why I want you to draw these charts or these diagrams so you see what is happening and can understand, okay, the bus is still moving in a positive direction, but it's slowing down, so therefore the acceleration needs to be negative. Okay? All right, so that's the second problem that we did that is on the practice problems. So let's do another problem. We're going to skip to let's do number 13. So 13, a motorcycle traveling at 20 meters per second decelerates at -5 meters per second squared. Okay. How long will it take to come to a complete stop? How long will it take to come to a complete stop? Okay, so a motorcycle traveling at 20 meters per second decelerates at -5 meters per second squared. How long will it take to come to a complete stop? Okay, so let's draw our chart. So here we go. I don't even know how to do this. Yeah, that's terrible. I am not a Picasso. That's why I say to you guys, don't worry about doing anything. So it's going at 20 meters per second. Negative. Okay. So here you go. Motorcycle that doesn't really look like a motorcycle. Handlebars. Woo, yay, let's go. All right. So, and it's coming to a complete stop. Okay. So this should be 0 meters per second. So your distance is going to be positive. It's still going this way. It's still going in a positive direction, but your acceleration is going to be negative because it's coming to a stop. So make your chart. So VI, VF, acceleration, time, and displacement. So what's your initial velocity? Your initial velocity is 20 meters per second because that's what it's starting at. What is going to be its final velocity? You want it to come to a complete stop, so its final velocity is going to be 0. And you have the acceleration, which is -5 meters per second squared, which is right here. And it tells you that it's decelerating, okay? What do you have to solve for? You have to solve for time. Again, you don't have distance, okay? So you're going to use, again, you're going to use the same equation. It's VF equals VI plus A times T. Your VF is 0. Your VI is 20 meters per second. Your acceleration is a -5 meters per second squared times T. Okay, so now you have 0 equals 20 meters per second minus 5 meters per second squared T. So now you have to subtract 20 meters per second from both sides. And you're left with -20 meters per second equals -5 meters per second squared times T. You're going to divide by a -5 meters per second squared. -5 meters per second squared. And what are you left with? Well, the meters cancel. This seconds cancels. So you're left with just seconds, which makes sense because you're solving for T. And T will equal a positive 4 seconds. Time must always be positive. If you come up with a negative time, it's wrong. You've done something wrong, okay? You've done something that isn't right, and you need to make sure that you have a positive value for time. Okay, so how long does it take for this motorcycle that's traveling at 20 meters per second to come to a complete stop? and doing it at a negative 5 meters per second squared, it's going to take 4 seconds. Okay, so now if you wanted to solve, if the follow-up part of this question was, okay, how much displacement does it take for it to come to a stop? Then you're going to have to solve using any one of the equations when you want to solve for distance. So whichever one it is that makes it easier to do, you can use. So let's make it easy. So final velocity is 0. We know that, right? So let's use D equals VF times T minus 0.5 times acceleration times T squared. Okay? That's the one we're going to use. Okay? So if we're using that, we can get rid of some of this because we already know the problem and we're just solving for distance here. Okay? We're solving for distance. So distance is, it's what we're solving for. Your final velocity is 0. Your time is 4 seconds minus 0.5 times negative 5 meters per second squared times 4 squared. Okay, so this cancels. 0 times whatever is 0. So now you're going to be left with negative 0.5 times negative 5 meters per second squared times 16 seconds. Okay, so you know that a negative half times 5 is going to be it's going to be a positive. So D equals 2.5 meters per second squared times 16 seconds. Okay, and remember this is second squared, sorry. So you're left with 16 times 2.5. Well, 16 times 2 is 32. 0.5 times 16 is 8. It's going to be the displacement is going to be 40 meters because this and this will cancel when you multiply it together. So your displacement is a positive 40 meters. So make sure you put the positive sign in, or you can say 40 meters to the right. Either one will be correct, okay, because that's what your displacement is. All right? Okay, we're going to do one more problem. I want to do one more with you. So that way, now you've seen how to solve with different equations. So let's clean this whole out. And let's go with let's see. I'm trying to pick a good one. Actually, let's do a free fall one. So let's do number 21. So an object is dropped. An object is dropped from a height, from some height. Okay, it falls from some height and is in free fall. How far does it fall in 3 seconds? So how far does it fall in 3 seconds? Okay, so you have an object being dropped. So here we are. Guy's up on the cliff. And here's the thing that he's going to drop. And he's going to drop it this way. Okay, your acceleration is going to be negative. okay, as is your displacement. Because remember, it starts from the top, starts from where it drops, okay? So that's what you're looking at. If we were going anywhere just this way, the acceleration would be positive and your displacement would be positive. All right, so draw your chart. So VI, VF, A, T, D. Okay, an object is dropped from some height. We don't know what the height is, okay? Because that's actually what we have to, in 3 seconds, that's what we have to solve for, is what the displacement is, okay? So it's in free fall. Free fall, we know the acceleration is going to be negative 9.8 meters per second squared. How far does it fall in 3 seconds? That's going to be your time. Okay. Do we know a final velocity? No, we don't. And we don't have it. Do we know an initial velocity? Yes, we do know an initial velocity. What is it? It starts in his hand. 0 meters per second. Okay. So now we're going to solve for distance. And we don't have the final velocity. So we're going to solve using this equation. D equals VI times T plus 0.5 acceleration times time squared. Okay. Now you just substitute in. Okay. You don't have the final velocity. This is the equation you're going to use. You're solving for D. D equals VI, which is 0 times T plus 0.5 times negative 9.8 times 3 squared. Okay. Actually, the square should be inside. All right. So D equals, this cancels. 0.5 times a negative 9.8 meters per second squared times 9 seconds squared. All right. So first things first, you can do it either way. It doesn't matter what you do. To me, what I would do is, to get this out, it would be a D equals negative 4.9 meters per second squared times 9 seconds squared. So 9 times 4.9. Well, okay, let's do it. 4.9, actually negative 4.9 times 9. 1, 36, 44. And it's going to be negative. It's negative 44.1. D equals a negative 44.1 meters because the second squareds cancel out. And that's your final answer. Your displacement is negative 44.1 meters or 44.1 meters down, because down is negative. Okay. If you wanted to solve for final velocity, you can. And you can actually do it the easy way. It would be VF equals VI plus A times T. Okay. VF is what you're solving for. VI is 0. So really it's just acceleration times time. Okay. And the final velocity is negative 9.8 times 3. So the final velocity is going to be a negative 9.8 times 3, 24, 27, 29. So it's going to be 29.4 meters per second, and it's going to be in a negative direction. Why? Because it's going down. So it's a negative 29.4 meters per second. And that's that. So it's really just a matter of using the equations, figuring out what you need to solve for, what you have, and then choosing the right equation once you've drawn everything out. All right, so really that's all it boils down to. It's really not that difficult to do. They're kind of easy, but you need to make sure that you are following the chart that's at the end and saying, okay, I don't have this, so this is what this is the equation I can use to solve for it.